Hey everyone, welcome back to another session of Docker. In this session, we'll see Docker engine architecture and its components, like what is Docker daemon and what is Docker REST API and Docker CLI. Next to it, we'll see what is Docker engine actually and try to understand how it's work. Next, we'll see Docker engine components one by one, and after that, we'll see how does Docker manage containers, like how it's managed container management history from where it came. We'll see. Next, we'll see introduction to OCI, like what is Open Container Initiative in Docker. Next, we'll also understand the modern Docker architecture, how it's worked, like there is container D, container theme. So all of this will cover in this video. Next, we'll see what happens if Docker daemon fails and what is Docker objects. So all of this will cover. So let's begin understand one by one. So first we'll see what is first we'll understand the Docker engine architecture. So Docker engine is the core software that allow you to run container on your system. So as we talked earlier, it's basically consists of three main components: Docker daemon, as you can see in the diagram, and the Docker REST API and the Docker CLI. So what is this Docker daemon? So it's a background process that manage everything. Like it's responsible for creating and managing image containers and volumes and networks. Next come Docker REST API. So it provide tools like Docker CLI to communicate with the Docker daemon, allow you to control Docker using commands, or you can write script also. Next come Docker CLI. So the CLI use to type Docker commands. We talk to the Docker daemon by the REST API. Next, we'll understand uh, what is Docker engine components we saw. We'll try to understand container management history. So in the beginning, Docker use LXC. So LXC is Linux container for container management. So LXC uses Linux kernel feature like namespace to isolate process, and next it use C groups to limit resource usage. Here you can see namespace for isolation and C groups for limit resource usage. And after that, from Docker version 0.9, Docker switched to its own execution environment called lib container. So that is written in Go. So this allowed Docker to interact directly with kernel features in OCI. So OCI, it was founded by Docker, Course and others, and developed with two important specifications. That is runtime specification. So it defines how containers should be created, start, stopped, and deleted. Next, image specification. It's define the structure of the container image. So now we'll see modern architecture of the Docker from version 1.11 plus. So here you can see Docker was broken down into smaller components for better flexibility. So here you can see container D. So it manages container life cycle like create, start, stop. Next come what is container sim. So it keeps container running if event daemon crashes. And after that you can see runc. So it's create container using kernel feature. Next question arises: what if Docker daemon fails, or if Docker is stopped? So if Docker stops, container keeps in running. So we will thank to container dsim. So container dsim monitors containers and keep things alive, making containers daemonless. Next, we'll see what is Docker object. So Docker works with four primary objects. You can see here you have image, container, network, and volume. So these are four primary objects of Docker. So image, it's read-only template, OS or app used to create containers. Next, container, it's running instance of an image. It's read-write. Next come network. So it's allow container to communicate with each other and the outside world. And after that, volume. So provide persistent storage for container, and that data survive container when it's restart. Next, we'll understand what is Docker registry. So it is stored Docker image, and it can be public. Example, you can have Docker Hub or private. By default, Docker looks for image on Docker Hub. Next, we'll understand how a container is created. We'll see step by step flow. So you run a command using Docker CLI. Then Docker CLI send the request by the REST API to the Docker daemon. Next step, Docker daemon checks if the image already exists locally. So if it present locally, it proceeds, and if no, it download the image from the registry. Like example I given Docker Hub. Next, we'll next step, Docker daemon uses the container D to create a container or bundle. And after that, in the fifth step, container C manage the container. And in the sixth step, runc talk to the Linux kernel to create the container using namespace or CG groups. So that's all about the container architecture, and we'll see more about Docker in next video. So that's all from this video, and thank you.